Hey guys, Chronicoverride here. Today's video is part 2 of my Redstone Tutorials series. If you haven't seen part 1, definitely go and watch that one first. The link will be down in the description below, or it should be in the top right hand corner of your video. We're going to go over some more advanced mechanics that I didn't cover in part 1. We're going to talk about clock circuits, vertical transmission, cutting signals, hoppers, droppers, dispensers, activator rails, switch tracks, note blocks, and piston behavior with slime blocks and honey blocks. So the first thing we're going to go over are clock circuits. Clock circuits are one of the most important circuits in all of Minecraft. They allow things to be powered on and off repeatedly on a timer that can be controlled. There's hundreds of different methods of creating clocks. I'm only going to show you 3 common methods that I use of creating clocks. This first one here is a repeater clock. So as you can see, the redstone torch is sending a signal through, and when it sends signal to the block that the torch is on, it inverts it to be off, allowing the signal to be turned on and off. And if you interact with the repeater and change the delay, you can change the speed of the clock to be faster or slower. The second type of clock that we're going to look at here is a redstone torch clock. This one has no repeaters. You have to use an odd number of torches in order for the signal to be sent around the clock, and the more torches that you add is basically the more delay that you're adding to the clock, and the slower that it'll go around in a circle. And the last one that we're going to look at here is the comparator clock. So if you guys remember correctly from the last lesson, comparators have 2 modes: compare and subtract. When you set the comparator to subtract mode and place a redstone torch so that the rear input has a signal strength of 15 and the side input has an alternating signal because the output is going on and off, you get a clock. So let me explain this to you guys. So the redstone torch is sending a signal of 15 into the rear of the comparator. The repeater is going on and off because the signal is subtracting 15 minus 15 or 15 minus 0, depending on whether or not this side input is on. And when it's on or off, it's inverting the signal going around the circle in a clock. So this first example is an alarm system. So you can hook this up any way that you really want to in survival mode, but let's say you're playing a realm with a whole bunch of people and you want to be alerted if one of your friends or somebody is coming to your house or trying to steal your stuff. You can set up a tripwire that will activate a clock, and it will make this bell ring repeatedly. So let's just say this lever was our tripwire. It'll send signal into the clock and it makes the bell ring repeatedly. So this one is a little bit more advanced. It's using command blocks and a clock circuit to make the piston go in and out, which is making the light go on and off. And the way that this is working is, as you can see, I have a clock circuit with a pretty significant amount of delay, so it's going pretty slow, and only one side of the circuit is on at one time. So there's a repeater going to that command block and a repeater going to that command block, and neither one of the repeaters will be on at the same time, like to trigger the commands at the same time. So this one is setting the block behind the piston to a redstone block right there, which powers it, and then once the clock reaches this one, it sets that same coordinate back to air, which is what causes this intermittent signal and allowing the light to go on and off. And our third example here uses a comparator clock in subtract mode to shoot arrows out of this dispenser system. So as you can see, when I flip the lever, it is now repeatedly shooting arrows. Alright, now we're going to take a look at vertical transmission. So there's a couple of ways that you can use to get redstone to travel vertically. This first one that we're going to look at is a redstone ladder that uses slabs. So when I flip this lever, it sends the signal through, and as you can see, the signal is still traveling up these blocks because they're slabs and not full blocks, and powering the contraptions still all the way up to 15 blocks. The second example here is a torch ladder, so same kind of idea, but you have to use a full block, and it's a torch, torch, torch. Has to be an odd number of torches, and as you can see, the signal will continue to travel all the way up. And then this last one is just sticky piston transmission. So when you connect a redstone block to a sticky piston and you power the sticky piston, it will power any redstone dust underneath it. Alright, now we're going to talk about different ways that different types of blocks interact with redstone wires. So in this first example, we have regular solid blocks, which as you can see will cut any redstone signal and not allow it to travel through the solid block like this vertically. Whereas in example 2, when we use a glass block, it does allow the wire to carry the signal through the solid glass block all the way up. And then the last example is what I already showed you guys, the slab redstone ladder, which will allow the redstone signal to travel through it. Alright, now let's talk about hoppers. Hoppers can be used to store and move items. They can be linked together when you crouch and place them next to each other to form a pipe that'll carry the items through them. And they can also take items from chests. So like if I put this hopper in that chest, it'll absorb it into that hopper and dump it into this chest. And as you can see, there's my hopper. They also interact with comparators. Comparators can be used to look inside as if it were like a chest or like any other container. And they also interact with droppers. So if I put the item in the dropper, again it'll drop it into the hopper. Hoppers can be powered, and when they are powered, they won't allow an item to travel through it. So if I were to take this out here and put a chest underneath here, as you can see, the items are not traveling through to the chest. And that's because we're sending a redstone signal into the hopper. But if we were to take it out, as you can see, the item's already drained into the chest below. Alright, moving on to droppers. A dropper does exactly as the name says, it drops items. It cannot activate the items that it's dropping. It will only drop items forward or into a hopper. So as you can see here, I have some tripwire hooks that I renamed key, and when I flip the lever here, it will drop that item forward, and then I have a key. If I were to have a hopper here, the hopper, if it's placed correctly, will pick up the key from the dropper. Droppers can also be used and are frequently used for simple key and lock systems. So as you see here, we have a key. If I take the key out and I put it into the dropper, the door opens. And this system works because the dropper is hooked up to this hopper, the hopper is hooked up to the comparator, and it has 4 stacks of 64, and when it has 1 stack of 63 with the 1 key missing, the door remains closed. But then when we put the key in, the door opens. Okay, and now we get to dispensers. Dispensers shoot or throw items. Certain items that you put in it can be activated and deployed by the dispensers. For example, in this dispenser here, we have a whole bunch of arrows, and when I press the button, it will shoot the arrow. In this one, I have a bunch of fire charges, and when I press the button, it'll actually activate the fire charge and turn it into a fireball when it's powered with the redstone, and it shoots it forward. Dispensers can also be used to deploy items. So as you can see in this one, we have minecarts with a rail, and if we hit the button, it will deploy a minecart. And very similarly here, this dispenser is filled with boats, and when we press the button and it's near water, it deploys a boat. Okay, Activator Rails. Activator Rails have a bunch of different functions. They can be powered by any redstone source, including detector rails. When powered, entities will be ejected from minecarts. So as you can see here, I have a pig in a minecart, and if we activate the activator rail and send the minecart with the pig, it will eject the pig out of the minecart. If we come over here, I have a dispenser filled with minecarts with TNT, and we have an activated activator rail here. When I send the minecart with the TNT, the activator rail will activate the TNT and cause it to explode. In this example here, we have a minecart with a hopper in it, and those pick up items from blocks above them when the activator rail is turned off. However, when you turn it on and throw an item on top, it will not collect the items anymore because it deactivates the hopper. And then over here, we have a switch track. So when you send a redstone signal to a track, it will switch direction. Alright, now let's take a look at note blocks. So note blocks emit a musical note when you send a redstone signal to them. You can change their note by clicking on them. And I have a whole bunch of note blocks here set up with certain notes in them. And when we press the button over here, you can see it will mimic the sounds that I have set for the note blocks. So if you guys wanted to recreate a song or create some kind of an alarm system, this is one way you could do it. And finally, we get to piston behavior with slime and honey blocks. So pistons can only push a total of 12 blocks. It can't push any more. So if you look here, we have a total of 12 blocks. 1, 2, 3, 4, 5, 6 slime, and 1, 2, 3, 4, 5, 6 gold. And when you have slime connected to a sticky piston with other blocks, it'll stick to any of the other blocks connected to the slime and move those as well. So as you can see, the gold blocks move with the slime up and down. However, if we were to add one extra block here, it won't move because it's beyond the 12 block capacity. And then we move it and it will work again. On this one, I'm showing you that because this gold block here is not connected to the stack with a piece of slime block or a honey block, it will not move with the other gold block. And because it's not a sticky piston, it's not going to bring the stack back. However, if we were to switch this out and put it back to a sticky piston, it'll bring the stack back. And similarly, if we were to replace this with a slime block, it'll now move that gold block. And honey works the same exact way as slime blocks do. If this tutorial helped you guys out, please like the video and subscribe to the channel. I am working on a bunch of other tutorials and I post weekly on YouTube. And as always, if you need any additional help or have any questions, feel free to hop into the Discord server. The link will be down in the description below. Or I stream weekly on Twitch. Feel free to hop into the Twitch chat and ask any questions you have there. Alright, until the next one.
Coming in, Big Mama.
I ain't got no guns, but I got a truck.